So now we're moving on for our hands-on sessions. So this would be about data cleaning. I hope you have all logged into your Google accounts. Let me show you that. So you can go to Google Collaboratory, and when you click it, you would be reverted to a page where you can code. So this is actually a notebook, something like a Jupyter notebook in the cloud, where it's facilitating mainly Python code. So you can just click plus code and go ahead with coding. But here we have already shared a Google Drive folder with you. I hope all of you got it. If you can, please go ahead and copy the notebook to your own drive, and then we'll start our hands-on session. Okay, so I shall go through the theory parts before. Data cleaning. So data cleaning is about figuring out whether we have missing values and is the data consistent. Say, if we have negative values with positive values, and also figuring out if the data is noisy. So these are like the main three types of data issues that we see. There can be many more, but we are focusing on a few issues at the moment. So that's about data cleaning. And then moving on to properly explain you what data cleaning is. So in this data table, you can see the age column, right? So in the age column, we have 21, 200, 24, 23, and a 2.8, and a minus 22, the red ones. So that's called noisy data. Actually, it can be incorrect data entry because I'm assuming Patrick is not 200 years old. So that is noisy data, and we have to take actions to clean that. So next up, we have another noisy data, which is indicated in red, the GPA, which is 234. So that is not the scale of the GPA at all. So those four red boxes, that can be classified as noisy data. Next up, we have inconsistent data. So if you see the student ID, it's starting from 100. Like each and every student ID starts from 100, and at the end, we have an AUC number. So that's inconsistency. And in the classification column, you have junior, sophomore, and senior, but then we have a SR and a JR, which is not consistent with how they have mentioned earlier. So it should be either senior and junior written properly. So we have to make amendments to those before we go ahead with data modeling. So next up, we have missing data, which is indicated in yellow. So if you can see, there's one student ID missing, but they have other data points for that, like Travis. We have to figure out what his student ID is. Maybe we can go back to the source and get it, or we can just put a number and make sure that so the student ID is something like a primary key. So we can maybe take amendments to that. And also we have a GPA here that's missing. So maybe if you're going with an analysis, we can maybe substitute a value for that. Moving on. So we are first, we are going to see how we are going to handle missing data. So that's missing data in the data sheet. So we have a data sheet here right now. And as you can see, in the pets column, we only have 62, 3, and 1. All the other entries are not there, like it's missing. And all those, the red boxes are indicating the missing values. So when it comes to handling missing data, we have main two ways. There are so many ways, but I'm only going to teach about two. So the first one is ignoring the tupper, and the second one is filling the missing values. So we can attribute the mean, or even some people do it with the median, or even the upper all over values of it. So the usual way is to attribute the mean. So if we check this particular data set, we can see the pets column, we only have 3 data points for so much of data rows. So maybe we can take that entire column off. And if we go with the emergency contact, for that also we only have 3 proper values. So it only has 4 proper values. So maybe we can take that column off as well. And if we check row wise, we have Tony who has 2 missing values. So when pets and the emergency contact is gone, Tony would be having just 1 missing value. So if we analyze row wise, we can see that Nick has 3 missing values. So maybe either we have to go ahead and impute it. So for the age, maybe we can get the average of all the other ages and put the mean for Nick and Carol. And for the same for years of seniority for Steve. Like that, we can go ahead with imputing the mean. So that is how, like, that would be the two main ways of figuring out how we can deal with missing values. Next up, we have handling noisy data. So in terms of handling noisy data, noisy data is mainly meaningless data that cannot be interpreted. So that is generated due to faulty data collection or data entry errors. So there are a few ways that we can handle noisy data. So I shall go back and show you what exactly noisy data is to remind you. So if you see age, we have 200 and minus 22. So those are not like proper ages to have, right? So that's noisy data, probably a data entry error. So to handle noisy data, we have the first method, which is the binding method. And here, if you can see the sorted data, that's in the right-hand corner, we have 4, 8, 15, and all of that. So we can categorize it into bins. So this, in the first section, they have shown it, they have made it into 3 bins, and they're smoothing the data by replacing the data point by the mean of it. So that's by smoothing it by means. And the other one is smoothing it by bin boundaries. So here they have 4, 8, and 15 in the bin. So they're using 4 twice and 15. So those are the edges of the boundary to fill up for the data. So in this particular example, we have 4 to 34. That's actually not like a very large range. Say if we have 4 to like 2000, this can actually be a difficult task when it comes to sorting data into bins. So the next one is we plot the data and we figure out the outliers. So noisy data is, say for example, age being 200. So we can see the when we plot it, all the other data points would fall into a very close cluster and the outliers will fall out of it. So in this picture, you can see now we can see a proper regression line and we have 3 outliers away from it. So maybe we should check about what exactly the outlier is. Maybe say we have like 105 for age. That is actually possible because there are people like that, and that is like a valid outlier. But if we have like 200 or 300, maybe we should omit that data point in our analysis. So moving on with the third problem we have when it comes to cleaning data, which is inconsistent data. So moving on to the example, if we check the region column, you can see east, south, and we have a north with the wrong spelling. So that's inconsistency. We have to make sure that it's proper, and we have another west which is WST and not WEST. So the problems like that, we have to make sure it's made before we go ahead with the analysis. So this, so when it comes to handling inconsistent data, A simple way would be when we have an Excel sheet, just to click the filter button and see if everything is in place. So if we click the if we click the filter button in the region, we would see North, NORTH, and also the North which says NORHT. So for that, we can maybe replace it. So that's one way of